Welcome to another podcast. In this episode, we're going to be taking a look at how to fill in a loan amortization schedule. Loan amortization schedules are a schedule of payments. So it's a schedule of payments anytime you take out a loan. By law, this has to be provided to you. So it's worth your time to understand kind of what's going on with payments involving a loan. That way you know kind of what you can expect to encounter, you know what the interest is, you know what the principal is, you know what each part of these problems are, and you can deal with it accordingly at that point. And for this particular example, what I'd like to do is do sort of a real-world example, if you will, that you're going to go in and you're going to purchase a car for $35,000. And typical with the purchase of a car is a finance amount. And so you're going to do a 3-year financing for cars. It's typically between 3 and 6 years. So financing means that you don't have the money right away, so you're going to have to basically take out a loan. And suppose that your interest rate here is 8%, and that's an annual rate, but you're going to be making monthly payments, so this is being compounded monthly. And what I want to do is I want to talk about filling in this table that I've provided, which is the amortization schedule. Specifically, I want to find the monthly payments. This is going to be the first thing that we're doing. We're going to find the monthly payment, PMT. And then we're going to calculate the interest, and it turns out in order to calculate the interest, we'll be using the simple interest command on each month because we're not folding that interest over. That's interest that gets paid in each payment, so it's appropriate to use simple interest here. And then to calculate the principal amount is the amount that actually pays off the loan. So this is actually pays down the loan. And then the balance is how much money you still owe. So we're going to talk about each of these as we go through. And the important thing to remember here is that when you make a monthly payment on something like a loan, not all of that money applies to actually paying off what you owe. It would be nice if it did, but they take out the interest first. So any interest that's owed for that month, they take out first, and then whatever's left over actually pays down the loan amount. So the first thing I should do is find the monthly payment, and I should note that for the first row here, I usually give a 0 row, and the 0 row is just indicated for the starting balance. And so the starting balance in this problem is $35,000, and in order to find the monthly payment, I could solve for the monthly payment by using the finance command, and the appropriate thing to put in the finance command would be a present value of $35,000. This is the initial size of the loan. Since we're paying off a loan, the future value should be 0. There shouldn't be any money left. I'm solving for the payment. So this is where the payment would go, and I'm solving for that variable. And then it's 8% compounded monthly for 3 years. So since the term, so this is called the term of the loan, since the term of the loan is 3 years, then it's 3 years, 12 payments a year, for a total of 36 payments. So we're just going to look at the first 3 payments in this table, but the table that the loan provider would give you would have 36, 37 rows for each of the payments. So let's go ahead and bring in our Math Studio window, and we'll go ahead and calculate that. So we've got the finance command. And we find that our payment per month is $1,096.77. So this is our monthly payment, $1,096.77. This is the payment that's made each and every month. So you can go ahead and fill in each of the monthly payments with that amount. Now the thing is, the very last payment you make might be slightly more or slightly less than this amount, but that's the monthly payment each month up until the very last payment. So the interest is calculated, like I said, using I equals PRT, and here P is the remaining balance. So this is the balance remaining. R is the rate, T is the time. The time here, because this is over the course of 1 month, the time is always going to be 1/12 if it's monthly payments. And so to calculate the interest here, I'm simply going to calculate for this first example. The interest would be the $35,000 that we owe times the rate of 8% times 1 month, and that value ends up being $233.33. So that is the amount of money that I would need to pay to interest for this example. Now the question is, okay, if I make almost an $1,100 payment and 200 something of it goes away, how much is left? That's what the principal part is going to tell you. And the principal, the way to find the principal is to take your monthly payment and then to subtract your interest. And so what you'll end up with at that point is, for this problem, the monthly payment is $1,096.77 minus the interest payment of $233.33, leaving you a total of $863.44. So that's the amount that actually affects the balance. So if I want to find the balance now, the balance is the previous balance of $35,000 minus the principal amount, which actually affects it. And this will bring the balance remaining down to $34,136.56. So that's how you handle each row. And the only thing that's going to change here is now moving on to the second month. When I go to calculate the interest, remember the principal is always the balance remaining. So the balance remaining for the first interest payment was $35,000, but now I owe less money. So when I go to calculate this interest payment, it's going to be the principal of, so this is the interest payment again.
For the interest here, you would end up with
$227
times the rate
and 58 cents
times the time.
And so if you calculate that,
once again,
if you subtract that
the
$227.58 from the $1,096.77, that will bring a new principal value of $869.19. And then this is a lot of times what I'll tell students: you take the previous value here, you subtract this value, and then that will give you the new remaining balance. And if you do that here, if you take $34,136.56 minus $869.19, then the remainder there is $33,267.37. And if I just keep going in this manner, the third interest payment would be $221.78. You should check that for yourself to see. The new principal payment would be $874.99. And then finally, the remaining balance after the third payment would be $32,392.38. Now, there's a couple of observations that I want to make here. The first is what's happening with the interest. You can see here that the amount of interest we pay is decreasing. So this decreases after each payment. So basically the idea is the more payments you make, the less interest you owe in each of those payments. In other words, most of the interest is calculated up front, which makes moving out of a house early on really bad because most of that money you spent making payments was going straight to interest. And so the opposite's true of principal. You can see here that the amount that goes to principal, because it's opposite of interest, it's actually going to increase. So these numbers will increase after each payment. And so there's this nice relationship between the two, but the basic idea here is that interest over time, interest gets paid mostly up front, and over time the amount that goes to interest decreases. So this is a loan amortization schedule. It basically shows you how much money you would have to pay at each point in time By law, people are required to give it to you, and so it's nice for us to be able to talk about it just so you'll know that if you ever buy a car or buy a house or something, you'll know what this sheet is that they're going to give you. It all revolves around being able to find the recurring monthly payment, which we did first, and then from there just filling in the rest of the table. All right, thank you for watching.